Hi, welcome to Cyber Secure channel. Continuing with CKS Exam Essentials, the curriculum outline broadly divided into 6 domains is flashed on the screen. In today's video, we will be concluding the 5th domain, which is supply chain security, having 20% weightage as per September 2024 format. Today, we will be discussing the static analysis of users' workload. Did you know over 90% of Kubernetes security breaches happen due to misconfiguration and vulnerable container images? But what if I told you there is a way to catch these issues before they even hit your cluster? Today we are diving into static analysis of Kubernetes workload, a must-know topic for the Certified Kubernetes Security Specialist exam and real-world security. The static analysis means checking your Kubernetes YAMLs and container images for problems before deployment. For the CKS exam, you will need to master 3 tools. The first is Trivy for vulnerabilities, second is Polaris for compliance, and Kubelinter for YAML hygiene. Let us break them down starting with Trivy. Trivy is like an X-ray scanner for your containers and manifest. It finds CVEs in images like outdated Nginx packages, misconfiguration in YAMLs like missing security context. It is like a security guard for your container and YAML. It checks for risky configuration. The command to run Trivy is flashed on the screen. Next up is Polaris. Imagine a report card for your cluster security. It scores workloads from 0 to 100 on criteria like are the containers running as root, which is bad, are CPU limit set, which is good. Run it with the command as flashed on the screen. Next up, Kubelinter. Kubelinter is like a picky friend who spots every YAML mistake, missing a liveness probe, privilege escalation risk. It will call you out. Command to remember is flashed on the screen. Quick but critical, always verify Kubernetes binaries with SHA-512 checksums. The tempered tools and binary means that game over. Command to check the installed Kubernetes binary with the original binaries is flashed on the screen. A real-world tip is to always check hash values when you download K8's binaries. Here's the golden combo. Use Trivy for CVE scanning like images and manifest, Kubelinter for strict YAML validation, Polaris for ongoing cluster compliance, and combine all these 3 in CI/CD pipeline for maximum security. And in the end, use SHA-512 sum to check the integrity of files and binaries. Now let's see these tools in action. Now first of all, checking the available namespaces and the available pods in each namespace. As we can see, there are 2 namespaces, application and infra. Let us see the pod in each namespace. We would like to extract the name of the images used by the pod for further scanning through different tools. There are 2 ways to extract the image name. The first is to use deployment information and the other is to use JSON path. Let's check both. First, using the deployment information. As you can see with -o wide switch, we are able to extract the name of the image used in deployment. But wait a minute, what if the pod is not part of a deployment? Then we use JSON path. Now using the JSON path option, I have provided the path in the presentation, But let us see how we got there. Now we are about to make two custom columns, pods and images, and display the name of the pods and images in them respectively. The JSON path will extract all the pods available in the particular namespace and display them under the column of the pod and their images under the column of image. As we can see that the name of the pod is available in metadata.name, while the name of the image is available in spec, containers, and image. As you can see, we have successfully extracted the name of the images. Now this is a handy command which is also available in kubectl cheat code in the documentation. So use it in the CKS exam. Now, as we got the name of the images, let's scan it through Trivy. Now scanning the image HTTPD with the Trivy. As you can see that we got the list of vulnerabilities: critical, high, medium, low, and other. Now saving this result in a file for our future consideration. Now the result is saved in the file. Now moving towards our next tool. You can see the number of vulnerabilities available through the Trivy command. Now moving towards the next tool, we have some YAML file which have some vulnerabilities. First of all, checking it manually. And then we will give it as an input to the static analysis tool. As you can see the images, as you can see the YAML file, there is some issues with the file. Through manual analysis, we are able to see, scenario 3 YAML file, we are able to see that the privilege, the security context privilege is true, which is a vulnerability concern. Now let us scan this YAML file through Kubelinter. We are getting the output in the JSON format. As you can see that we got an output which provide detail of the security issues and the solution to resolve the same. Like the container is running in the privilege mode and some security context issues. We can save this result for our future consideration, and we can use the information to make our deployment more security efficient. Now let's move on. Let us scan the same YAML file with Polaris. Now scanning the YAML file through Polaris, and we get a result in JSON format. Now, as you can see the result, it is like a compliance report which tells you that which configuration should work in which manner. Like the privilege escalation should not be allowed, the file system should be read-only, and many more. Now let's move on. Let us now check the integrity of the Kubernetes binaries. Let us check the kubectl version first. Now let us download the binaries from the legitimate source. The binaries with the same version as installed on our Kubernetes cluster. Now unzipping the downloaded file. And then calculating the hash value of the kubectl binary that we just downloaded, which is present in Kubernetes server and bin. Now we have calculated the kubectl, the hash value of the kubectl binary we just downloaded from a legitimate site. Now checking the hash value of the kubectl binary that is already installed in our Kubernetes cluster. It will be present in the bin folder. Let's search the binary, the kubectl binary, and then calculate the hash value of the installed binary. Yeah. As you can see that both of the hash values are equal, which means that a legitimate binary is running in our Kubernetes cluster. Now let's recap. We discussed some tools for static analysis of the workload and the images. And then we validated the hash value of the Kubernetes binaries. The tools we discussed are Trivy to find the vulnerabilities, Polaris to grade your cluster, Kubelinter to polish YAMLs, and SHA-512 sum to calculate the hash value. Now I would love to hear from you. Which tools are you more excited to use? Drop a comment, and if this helped, subscribe for more CKS tips. Thank you very much.